YouTube, J. Kilroy here, back for a little shop ADHD, and today we're going to have what I refer to as a experience moment. In other words, learn from my mistakes. I'd like to think that in most cases I learn from my mistakes, but we're going to discuss a mistake. It wasn't a mistake, it was a design decision that I made a while back on a product. This is several years ago actually, and what I learned from the decision that I made, it involves this pulley sheave that we made on another shop ADHD video when we used the gang milling setup on the big KT to side cut this profile in one pass, and check the cards to the link. Anyway, so this pulley sheave here goes on an application where it drives, there's a shaft, keyed shaft, that turns an encoder. So no appreciable torque on the shaft at all. Total static load on the pulley, 35 pounds max static load. The bearings that I use are little 1/2 inch ID stainless steel bearings. The reason they're stainless steel is because these go on a kind of a marine application. Anyway, 1/2 inch ID, 35 pound static load, right? Maximum speed maybe 2 or 3 RPM, or I don't know, maybe 10 RPM, low speed. So I use a 1/2 inch shaft. Originally, I used a 1/2 inch shaft with a key, and typical key in a 1/2 inch shaft is going to be maybe an 1/8 inch key, probably not any bigger than that. That's pretty standard for a 1/2 inch shaft, maybe a metric size, maybe a 4 or 5 millimeter key, and that's what I used, and I had a problem. And I'll give you a second to post down below what you think the problem was. Take your time. We'll count this out. Give you about 15 seconds to post what you think my problem was with that shaft and key setup. I'll just go ahead and tell you that the problem involved the shaft and the key. While you're typing that, we're going to do a little demo of the auto tapping cycle on the Alls metal drill press here shortly, that I incorporated into the depth stop that we did the series of videos on, so check that out. Alright, so we're going to use the auto tapping function here with the stop, depth stop that we did for the Alls metal drill press here a while back. It's a stainless steel, it's a 3/16 stainless steel sprocket, drilled and getting ready to be tapped for 1/4 by 20. There you go. Obviously not the kind of job that you normally would use this on. You could use the foot pedal for a one-off like this, but just wanted to demo. Okay. That should be enough time right there to enter what you thought my problem was. If not, pause it and go into length. I would love detailed analyses of the design. What was the problem? The problem was with 35-pound static load. This thing is mounted on a floating platform. It sees some amount of wave action. Not large. This is freshwater lakes, reservoirs. So not Great Lakes and not Gulf of Mexico, not the Pacific Ocean. So smallish waves made by recreational boats and the like. The pounding on the deployed weight of max 35 pounds. The pounding of the movement of the platform caused the bore of this pulley, 1 inch thick, ultra high molecular weight polyethylene, quality stuff, but the pounding of that minimal amount of weight and the 1/2 inch bore wallowed out. It deformed the ID of the bore to such an extent that the key would not grab. And there you go. And then operation became, say, less than consistent, right? So, what did I do about it? What would you do about it? How would you best key, shaft and key this pulley using a 1/2 inch shaft to a small encoder? How would you key this pulley to keep that from happening? I'm looking for your ideas. I can tell you what I did and what works for me, but I'm always looking for other ideas. So now hit pause, go down below and type out and tell me what you would do to keep that from happening. The bore of this pulley deformed under load, which is minimal, to such an extent that the key would not engage, and it was a I want to say it was a double height 1/8 inch key. So it was 1/8 of an inch into the shaft, 1/8 of an inch into the pulley. I wouldn't have believed this would have happened to myself, but it did. So give me now your recommendations. All right, we're back. Your recommendations have been made, and I look forward to reading them. What did I do to key this pulley so that it would not slip on that 1/2 inch shaft? Well, I'm going to show you, because we're going to get ready to do this one. I'm going to show you what we're going to do. Let me give you a little hint right now. Here's your hint. The hint is a 5/8 inch square brooch. Still got pieces of plastic in it from the last time I made one of these. That's right. So what I do is broach this out to 5/8 inch square. I take a 5/8 inch piece of stainless steel, drill through for a 1/2 inch shaft, drill and ream for a 1/2 inch shaft, and boom, I have a square drive shaft for the pulley, and it works great. So this is how I chose to rectify this problem. While the static load was minimal compared to all the components in the design, 35-pound maximum static load or 30-pound maximum. In most cases, typical static load is less than 15. I would have never anticipated this problem. What I didn't factor in was the dynamic load caused by the acceleration and deceleration of the floating platform on the water surface, and the effects, the shock effects of that on the pulley. So what we're going to do right now is we're going to broach this out. I'm going to show you how I do it. I don't have a press that will press, I don't have an arbor press that will press this kind of length, right? So I kind of use a novel approach. And this only works because this pulley is polyethylene. If it was aluminum or steel, I doubt this would work. So let me show you what I do. So here you go. Last push. I said I just push the broach through with the tailstock. And there we go. 5/8 inch square hole. So there you go. 5/8 inch square hole. Mostly square. Just like with metal, there's a little bit of bulge in the side wall, but it works for this purpose just fine. So now what we're going to do is we're going to make the 5/8 inch block, square block that goes in here that gives us our drive portion of the axle. All right, YouTube, so we've got our square hole broached in the center of the pulley, and then I've got some square 303 stock here, not stuff that grows on trees, and we're going to drill it before we cut it. The reason I say that is because I'm holding it in this 5/8 inch square 5C copper, and it just holds a little better when you got a little more material, and if you do accidentally push the material back into the collar a little bit, it's not a pain in the butt to get out. So that's what we're going to do now. I'll find my key. Where is it? There we go. Nice generous chamfer. I'm going to get a center drill and drill it. got to drill at least 1 inch. But since we're going to ream the hole out, I don't want to hit the bottom. We're going to drill probably 1.25 inches. Even though it's 303, I know it's not 316 or 304 or anything like that. It's still stainless steel. So when you drill it, you cut it, cut it. Don't play around with it. Just get right with it. And make sure you're taking a good chip. Your chip load, good heavy chip load, so that you don't accidentally work hard in something and, you know, turn your drill bit into a piece of rebar. Remember, never bottom out your reamer, never run your reamer backwards. Slow it down just a little bit. We're going to go with the A-Bomb 79 Dark Goodness. One push. An inch, a little over an inch. That's it. When I center drilled that hole, I might have got out a little too fast and got a little off center there, but this will work out fine. Let's go ahead and get that out of there, and then we will go cut it. There's our drive key, basically, you would say. Now we got to make the axle for it to go on. Alright, so then we got our shaft. It's also stainless steel. And here's our square key, I like to call it. It is retained 0.55 inches from one end. And what I use for that is this Loctite retaining compound. Now you gotta leave room for it. You can't have a little, you can't have no gap and expect to get any Loctite in there and actually have it doing the work. So anyway, that's how that gets retained on there, and it works fine. Remember, there's no torque on this assembly except for an encoder. Here's the encoder. It's a little through bore AccuCoder by Encoder Products. It's got a 1/2 inch bore, 1,000 pulse per revolution count. No affiliation, but I really enjoy and have worked with Encoder Products for a long time. And make a quality product at a reasonable price. So moving on, I mean, well, what do we learn from this, right? Why did the original shaft and key assembly not work? Because I had a material that was ductile, like all materials are, right? Everything's made of rubber. And what I didn't account for the dynamic forces, and I didn't have enough surface area on my shaft to spread the load out wide enough to reduce that deformation which caused the key not to work. This solves that problem, right? Gives me a lot of surface area, and any deformation that might happen isn't going to cause the key, in this case the square block, to not grip. So yeah, you know, designing things, building things, inventing things, an iterative process. And this was just something that, you know, an iteration that I went through, and it cost me some time and money, but I did learn from it and was able to make my product better. So there you go. Haven't been making a lot of videos lately. I apologize. I really do apologize. If you want to find out why, I got a new employment situation. If you want to find out why, you got to come to the bash this coming weekend. I'm going to be there cooking, trying to find every bit of shade known to man. Stan sent a picture today of the thermometer well past 100. It's a dry heat. Of course, here I don't have the dry heat. Humidity's been literally bumping 80%. At night, temperatures have been well into the 90s, so it has been hot and miserable as usual from Mississippi. Got to get the AC fixed. The other reason I'm making a lot of videos is because, and to be honest, I'm in pain. Hip pain. And I'm going to show you a new stool I got here that I'm really enjoying and has really helped with this situation. My wife bought me this for Father's Day, and it's a little early, and it's really helped out a lot. But all right, so here's the stool my wife gave me. It's a saddle style stool, so it you sit on it like a saddle. The seat pivots front to back. Let me loosen it up so I can pivot it here. Yep. It's spring loaded. It pivots front to back, and it's lockable. It's gas adjust, and it comes up to a real nice height. Here you see it next to the bench. Very comfortable. You can't slouch in this type of stool, so really do like this stool, and it has improved the discomfort situation being at the bench and the lathe. So this is very nice. She got this off of Amazon. I want to say it was a little over $100, and well worth it. Yeah, I've been having some pretty significant hip pain standing. If I'm standing straight up, no problem. If I lean over just a little bit, like when you're standing at a lathe, when you're standing at a mill, when you're standing at a workbench, it hurts bad, right? And I am seeking medical attention for this, because it is painful. But one of the things that I can do to improve this situation for myself, and I'm going to be looking to you guys for help in this regard, is I need to drop the weight, right? I weigh in at about 245. When I moved to Vicksburg, I weighed in at about 180. Well, there you go. So, you know, I got to lose the weight. And I'm asking my friends and my viewers for support in that effort, because it's going to be difficult. But I can tell you right now, it's not as difficult as this feeling. It feels like somebody's sticking a knife in your hip when you're standing here at the workbench, right? So we got to take care of each other, and that's one way we can do it. So more to come in that regard. I'm going to officially kick off my weight loss effort as soon as I get back from stands. You don't think I'm a dummy, do you? So anyway, we're going to kick that off, and I'm going to be looking for support from you guys. I'm going to be getting back on the videos, getting back on the projects. I owe some people some projects. I owe Randy Richard some projects. I owe A-Bomb some projects. I owe a lot of people some projects. So if you want to find out what's happened, come to the bash, watch the bash. We're going to have some interesting games. I'm going to go over my game right now, okay? Let's go over what I'm doing as an event. In my mind, the most important thing that we do as machinists, metalworkers, fabricators, builders is measure. Measuring is the most important skill. So what we're going to do, my game is going to be a measuring game. Let me show you the things we're going to measure. I got a ring gauge setting fixture here. I'll tell you right now, it's not to a common size. We're going to be measuring ID with snap gauges and mics. No digital tools allowed. We're going to be measuring OD. Plug gauge. Again, not a common size. No digital tools allowed. And we're going to be measuring height. There's a gauge block in here. Now, I haven't talked to Stan about it, but when I get to Stan's, we're going to take this gauge block, we're going to put this baby on his surface grinder, and he's going to kiss some off of this gauge block, so it's not going to be a standard size either, right? No digital tools. Tools will be provided. So you'll have mics, snap gauges, height gauge. You'll measure all three items. You'll put your numbers down. Now, how do we make this a contest, you say? What about a tie? Well, one of the things we're going to do, we're going to time you while you do it. So, doing it quickly, because we're people that work in working environments. We've got to turn and burn, make some money. You know, you can't spend all day getting one OD measurement. So I'm going to time you. But you say to yourself, well, what good is a sloppy timed measurement? Well, what I'm going to do is I'm going to weight the results towards accuracy. Accuracy is going to matter more. I'm going to take your total measurement of all three measurements. I'm going to calculate the absolute difference against the total of all three standard measurements. I'm going to take your difference in tenths, multiply it by 100, and add your time, okay, in seconds. So time matters, accuracy matters. No digital instruments allowed. So that's going to be the contest. And I think it's going to be a lot of fun. It's not going to be the four-jaw contest, but everybody needs to be able to make quality measurements. So, and everybody does. This is something that everybody does in their shop as well. Everybody measures in their shop. So get out your tools and take some measurements. If you're the kind of person that depends on digital mics and you're going to be at the bash, you might want to brush up on reading a traditional mic because you won't be using a digital. And there'll be plenty of people there, including myself, that'll be glad to give you some pointers on mic technique. Anyway, so I'm heading to the bash this Friday. Be there Friday night, be at the bash Saturday, be there Saturday night. Unfortunately, flying out Sunday, have to cut this trip a little short. But looking forward to getting back in the shop, getting back in front of my viewers, my friends, and starting some interesting projects. So stay safe in the shop, and I'll be back with you soon.